everyone. Good afternoon for those on the West Coast. Good evening for rest of the folks, I guess. So thanks, Phil, for the introduction. So today I'm going to talk about who broke my crypto. This is a beginner level talk for any of you who have a question. But I do have a lot of pop culture and anime references, just for fun and more relevant. So this is Among Us game reference. Basically, they want to know. I'm not mad. I just want to know who broke it. So it kind of sticks with my talk. And a disclaimer here: things that you won't learn in this talk. You won't be learning anything about cryptocurrency, although there is a crypto in the talk name. You won't learn anything about Bitcoin or blockchain. I'm sorry. And this is Prince Zuko from the Fire Kingdom, so he's crying. But here's the agenda for today. And you have 5 sections. And basically, we'll go through a story of what happened. And on the left side, I don't know why I added Darth Vader, because I like him, I guess. So you have him right there. All right. The problem. So this happened a few months ago. So on a daily basis at work, we deploy all of our software onto AWS and we manage our things from there. So I cannot entirely disclose what operating system it is running, but I can say it's a variant of Linux. So when I'm talking about EC2 instance in this talk, it's a instance or a Linux instance in AWS, and I'm trying to connect to it or SSH to it, as we all do. And the thing is, I also have Elastic IP to it, so I can directly use a username and SSH to it instead of a key or something. But it was bailing out on me, so here's Naruto. He's another favorite of mine. He's crying, so back-to-back 2 crying slides. So when I saw this issue, first thing we have to do as an engineer is trying to figure out what went wrong and trying to recall whether it worked before. So yes, until Friday, the week before, it is working fine. I shut down my work, come back on Monday, and I'm unable to access it. So as every engineer does, I obviously ping to the instance, right? See, hey, whether I'm able, is it live? The instance is down. Do I need to start it? Or things like that. Everything is fine. I mean, AWS says it's running and I don't see any alerts on it, no memory issues on it, and no package drop. And also have list of things. So I didn't change anything on instance. And for host machine, I use the machine given by Cisco, it's like a RHEL Red Hat instance. I SSH from there. So this is confused Homer Simpson look. That I was in the same situation there. I was like breaking my mind, like, okay, what's happening here? I don't know what's going on. So next comes the chase. With some knowledge I had about debugging things, I thought, okay, maybe let's see what's going on here. So basic tool everybody can use is a netcat, right? Just like hit this command and see it as DB, the IP of the EC2 instance or the Elastic IP. And since I'm doing SSH, so SSH runs on port 22. So just Q22 there. And the sample output, as you can see, it will say, hey, I'm able to connect to this. I can do netcat to this and it succeeded. Okay, that's good. And if anybody wants to know more about it, so Z is a 0 IO mode for scanning and V is the verbose mode, which will actually help us in scripting. So that's netcat. So netcat is okay. And I also know more utilities. Nping, right? So I do like nping and I give a count of 5. I give like a protocol of TCP. And again, as usual, it's SSH, so port 22. And I give the Elastic IP. I tried that too. I mean, I'm getting desperate around here. I was like, okay, I tried netcat, but SSH doesn't work. Netcat says everything is fine. Okay, I'm going to try nping now. And even nping comes back with a successful result. It will say, hey, 5 items, all of them are successful. I tried 100 items that day and everything says, it looks fine. Your instance is fine. There is nothing wrong with that. So you got to check what's going on here. So at this point, with the limited knowledge I had, I was like, okay, I don't know how to debug this. So somebody has to be helping me to get me to, resolve this issue. So I was like, I know one more thing. SSH, you can use a flag, the same verbose flag that you've seen before, into 3 levels. So for example, like SSH-V, If you try that, it will say from your end what's actually happening. If you do SSH-VV, you'll get some little amount of logs from both ends, from the client and the server or host and the guest. And if you type VVV, you'll get most of the information of what's happening on both ends. So I did that. And again, I get the same thing. I got the logs, but it was losing connection and I had no error message, no warning message. It just lost connection. So as you know, I was feeling really sad. The next thing I could do was contacting AWS support is like, hey guys, I don't know, I can't connect to my instance. I don't know what's happening. So the rep was very patient. They were walking me through it. The first thing they'll tell me is, hey man, did you try SSH BBB? I was like, dude, that's the first thing, or maybe the third thing that I did. Like, okay, I still lost connection. Okay, then he's like, okay, let's go a level up. Create a packet capture. Okay, you know, TCP dump, right? It's pretty simple. So uh, if you have like a root privilege on a machine or something like that, sudo -i helps you get to the privilege. And you can set up a TCP dump where you create a capture file. And you also basically give a port and S start for the snapshot length. So basically the I is interface. So at this point, I will provide the elastic details here. So basically on my machine, I'm starting a TCP dump. So the later, all the commands that I start here, TCP dump is collecting and capturing it into a packet capture file that I can use for further analysis and see if there are any discrepancies. So this is actually a good idea. I didn't think of that. I should have done TCP dump before contacting the support, but anyway, I learned something new. So this is a command to install. So you can use it in Ubuntu system or Red Hat system, and it's open source, so it's free to use. And you don't have to take screenshots on this slide deck. I'm going to share it after the talk. So, and for those who are confusion about what W means, it's just a file name. That's like the packet capture file that I'm giving here. So we tried this, but you know, TCP dump didn't say anything. It said, you know, everything looks fine. Then we're gonna go a level up right now. So we tried like that, didn't work. We tried nping, didn't work. We tried regular ping, didn't work. SSH VVV didn't work. And we also tried TCP dump, didn't work. So I'm getting really desperate around here, like, okay, what's going on? So there is this thing called traceroute and also MTR, which is my traceroute. So traceroute actually helps diagnose if there is a network issue in a system. And you can view it over ports like 22 or 443. So 22 is for SSH and 443, as you know, it's for HTTPS. And MTR is more better because it combines the ability of a traceroute and also ping into one place. So it's kind of a better debugger for us. So, you know, as Mario says, you know, we are leveling up in the game. So this is another reference of mine. So to set up MTR, you just do like MTR, you give a count. I'm just giving a count of 50. And I give like a no DNS, like do not need to resolve any hosting because I'm giving directly the IP, and also show IPs, which will display the hostname IPs and also the IP numbers. And report wide, as you can see, it will give a wide report mode. That means host names are not cut if it's already there. And we're also pulling a full report. Basically, it will print the report for the number of cycles that we have, rather than like a full, like a truncated report. And as I said, I was trying HTTPS. I don't know why, because I was desperate enough. So I was trying HTTPS, and I was also trying port 22. In addition to MTR, you can also do traceroute. So traceroute is pretty simple. You just give the TCP traceroute, elastic IP, port 22, and if you want to add like a TCP on the top for verification, you can just do the second command here, TCP dash capital T, port 22, and elastic IP. So yeah, we did level up. We tried my traceroute and traceroute, but maybe as you have guessed, that didn't work. I mean, I don't know what went wrong. I mean, I used all my debugging skills. I even got database support to work with me, and I couldn't access to my instance. So at this point, a couple of days passed. Still, I'm paying for the instances on AWS, but unable to access to it or do anything. I really miss my instances. I really miss working on them. I was like, okay, let me think what might have changed. Maybe I missed something. So I go check my email and I realized nothing changed on the instance itself, but the host I'm accessing it from. So our IT guys upgraded our RHEL 6 system to a RHEL 8 over the weekend. And I went and checked, okay, LSB release A. It said, okay, release 8.1. So, okay, this is a good news. Something has changed. And if somebody is curious about what this code name Utpa is, it's just like internet related chat of the engineer who passed away in 2016. So this code name was chosen for Relate as a tribute to Larry. So um, he's somewhere listening to us. All right. So something has changed, but what exactly? Let's take a step back. So at this point, before debugging what's going on with the instance, maybe it's a better way for me to think, how does SSH work? So, Mark Stamp wrote a great book. I always refer to this book uh, about everything on information security. And he explains it with a simple examples of Alice, Bob, and Trudy, where basically Alice and Bob are communicating with each other in crypto, basically exchanging information, and Trudy is a bad person. So since right now we do not want any Trudy here, we just think about regular SSH, right? So how does SSH work? So there is a Alice here, there is a Bob here. Alice, when she sends a message to Bob, she proposes a crypto algorithm, right? You can see CP, crypto proposed, and Bob responds with a crypto selected message right here. So the first two steps, as you can see, as an engineer, I have worked all these days and I completely forgot how SSH works. But when I went back to the textbook, it's quite clear that Alice is sending a crypto algorithm or proposing something so that Bob can agree on and respond to it before SSH connection happens. Okay, good. We got a clue. So maybe that might be it. Maybe that might not be it. So let's take a step back. Go ahead and check Google for Red Hat documentation. What's going on? So what Red Hat did was when they moved to Red Hat 8, they updated their SSH version from OpenSSH 1 to OpenSSH 2, which basically removed some of the vulnerable crypto algorithms. So, for example, Red Hat 6 allowed some vulnerable algorithms. In Red Hat 8, they made sure weak crypto algorithms are not allowed to make sure your system is not vulnerable. So that is a good thing. All right. So if you go to Relate system right now, and you can see it on internet, any of you, yeah, if you have a Relate instance, it shows this following algorithms. Okay. We have like AES, CBC, CTR, GCMs, and everything. Okay. That looks good. All right. But although in Red Hat documentation, they say this, all of these are supported, if you look closely, there is an open bug, which is not yet fixed in Red Hat, where GCM ciphers were not being allowed or being blocked. So yes, GCM ciphers are, yes, they are strong. They're not too vulnerable. That's the reason Red Hat allowed them in the first place when they upgraded their operating system. But there was a bug at the operating system level, which kind of blocked, although a client is trying to connect or a server is trying to connect via this crypto exchange algorithm, it was getting blocked because of a genuine bug. And I did not know about that. So basically, whenever FFs mode is enabled on your Red Hat system, you're going to hit this bug. So this is a very specific scenario that happens. So now we know something. Red Hat system has a bug, and GCM ciphers are not being allowed when it's in FFs mode. So let's go back to a host machine. So when you do SSH VVV, something looks fishy, right? I'm trying to see AES 256 GCM, and I'm trying to propose that to Red Hat and saying, hey, that means my instance is saying, hey, Red Hat, please connect using this algorithm. And Red Hat is saying, okay, I'll connect. But as you know, Red Hat has a bug when FIPS is enabled. This algorithm itself is blocked. Obviously, connection is closed. I mean, there is no question about that. This was so simple, right? I mean, this is a small scenario which is a very, very corner case where very rarely you would hit it in a software. It's not straightforward that you hit kind of these kind of instances in a software where your availability becomes 0%. So when you have an instance and you are the rightful user to it and you have the right credentials, your availability should be 100%. But here Because of the corner case, you're completely blocked out of it. And here, when I went to my EC2 instance, you can do like cat ssh config from this folder. It says these are my ciphers. Okay, something's wrong here. Okay, the preferential order is GCM ciphers are the first, then I have AES ciphers, and then I have 3DES ciphers. If I go back here, AES ciphers are also allowed here. So that means there is a bug in my code on my EC2 instance where after it's trying to connect using the first crypto exchange algorithm, it's ignoring the rest. I mean, if this fails, it should propose this one. If this fails, then it has to propose the next one. It should not bail out on me in the first instance. So that means it's a genuine bug. And as a software test engineer, obviously I like finding bugs and also I like finding issues. This was something which like really enjoyable because I kind of found what the issue is. And the best way to there is a simple workaround for this that will go in the next slide. So, so basically the instance is defaulting to GCM ciphers. So how to fix that? That bug is fixed. And there is a genuine Red Hat bug, which is not fixed yet, which is blocking GCM ciphers in FIPS mode. And the simple workaround was just add -C option with a cipher that is common in both places. So for example, here I have like AES 256 CTR or AES 128 CTR. If I have this here, I can just add -C option on my SSH and voila, that SSH goes through. And this kind of took me 1 week to figure out. But yes, at the end of the day, it was a happy ending. And I figured out what actually happened and who broke my crypto. It was my code. So that pretty much summarizes my slide.